Welcome in Core. Astronomers have just refined the path of asteroid 2024 YR4. At first, it looked like Earth was in trouble with over a 3% chance of impact in December 2032, the highest ever recorded for any asteroid. But new observations, including data from the James Webb Space Telescope, changed the story. Earth is safe. Keep watching this video to know more about this topic. Discovery and risk reassessment. Asteroid 2024 YR4 was first detected on December 28, 2024 by the Atlas Survey Telescope in Chile. At that time, it had already made its closest pass to Earth, hidden in the glare of the sun. The delay in discovery highlights one of the biggest challenges in planetary defense. Objects approaching from near the sun are difficult to detect. Initial orbital models suggested YR4 could strike Earth in 2032. Each new observation slightly changed the calculated path, sometimes raising the risk, sometimes lowering it. By February 2025, the chance of impact peaked at 3.1%, enough to rank it the riskiest asteroid ever observed. YR4 is estimated at 60 m in diameter. That makes it small compared to the massive asteroids that cause mass extinctions on Earth's path, but still dangerous. An object this size could devastate a region if it struck our planet, a category often described as a city killer. To refine its orbit, astronomers turned to the world's most advanced instruments. The European Southern Observatory's Very Large Telescope and the James Webb Space Telescope provided the precision needed. JWST, operating above Earth's atmosphere, extended observations longer than ground-based telescopes could manage. By mid-2025, the improved data ruled out an Earth impact. That was a relief, but the new calculations pointed to another possibility, a collision with the Moon. As of June, the chance stood at 4.3%. While the odds still favor a miss, they are high enough to model potential outcomes and consider how to respond. For now, the asteroid has faded beyond the reach of telescopes. It will not be visible again until 2028, when new observations will either lower the risk further or confirm that the Moon remains in its path. What a Moon impact would look like. If YR4 were to strike the Moon, the event would be unlike anything modern humanity has witnessed. Although modest compared to larger asteroids, a body about 60 m wide, traveling at cosmic speeds, would release enormous energy on impact. Models suggest a collision could excavate a crater around 1 kilometer in diameter. For context, that's similar to Arizona's meteor crater, but on the Moon, it would stand out as the largest new impact in 5,000 years. The initial flash would be visible from Earth, glowing for several seconds. For the first time, astronomers and the public alike could watch a significant lunar impact unfold in real time. But the spectacle would not be the only consequence. The strike could eject up to 100 million kilograms of dust and rock into space. Most would fall back onto the lunar surface, but some fragment could escape and head toward Earth. That material would arrive as an intense meteor shower. Fine grains of dust would burn up in the atmosphere, harmless to people on the ground, but dazzling to watch. For satellites, however, it could be another story. Even millimeter-sized debris traveling faster than a bullet can damage sensitive instruments, solar panels, or communication systems. Models suggest satellites could experience the equivalent of a decade of normal debris exposure condensed into a few days. On the lunar surface, the risks would be more direct. By the 2030s, international space programs are likely to have astronauts, research bases, and equipment operating on the Moon. Flying debris from the impact could endanger habitats or infrastructure. Without an atmosphere to slow incoming fragments, even small pieces could pose significant hazards. For Earth, the risk is negligible. The atmosphere would burn up debris, leaving only pebbles. The real concern lies with satellites and lunar missions, which may need extra safeguards. Scientific value and future outlook. While the risks are real, scientists also see a rare opportunity. The Moon is covered in craters, but nearly all formed in the distant past. If YR4 were to strike, it would provide the first chance to study a large impact as it happens. Observations from Earth, satellites in orbit, and landers on the Moon could track every stage from the flash to the dispersal of debris. That data could refine our understanding of impact processes, crater formation, and how energy transfers through planetary surfaces. For planetary scientists, it would be an unprecedented natural experiment. It also broadens the conversation about planetary defense. Until recently, protecting Earth was the focus. The success of NASA's DART mission in 2022, which altered the orbit of asteroid Dorcas, proved that deflection is possible. But as humanity builds infrastructure beyond Earth, the definition of defense may expand to include protecting the moon, satellites, and future outposts. If, in 2028, observation confirm a significant lunar risk, agencies may need to debate whether a deflection mission is justified. Moving an asteroid away from the moon, not Earth, would be a new challenge for planetary defense. Meanwhile, new tools are coming online. NASA's NEO-Surveyor launching in 2027 and ISRO's NEOMIR satellite in the early 2030s will target asteroids approaching from near the Sun, the same blind spot that hid YR4 until it had already passed Earth. Combined with the upcoming Vera Rubin Observatory, which will detect thousands of new asteroids, these instruments will strengthen early warning systems. Most scientists expect that future data will reduce the odds of a lunar impact. But the episode is already valuable. It demonstrates how quickly probabilities can shift, how faint and elusive small asteroids can be, and how expanding human activity in space requires rethinking what planetary defense really means. Outro. Asteroid 2024 YR4 no longer threatens Earth, but it could strike the moon in 2032, creating a visible crater, a meteor shower, and risk for satellites and missions. For scientists, it's a rare chance to study an impact in real time. Whether it hits or misses, YR4 reminds us that space is dynamic and we must stay prepared, stay curious, stay ready. The cosmos is always moving. Thanks for watching Dark Core.